Hello everyone and welcome to webinar How to Solve Challenges Faster and Easier with a Digital Twin. This webinar is organized together Klinkman, Rockwell Automation and Focus Law. My name is Pasi Lehto and I am Industrial Control Solution Team Leader from Klinkman Helsinki office. Klinkman is authorized distributor of Rockwell Automation, means that we are your local support, your local engineers trainer, and Rockwell Automation technologies and software supplier in Finland and Baltics. I'm happy that you have decided to use 1 hour from your business time to digital twin inspiration. Emulate 3D and their intelligence softwares are part of Rockwell Automation, and Klinkman is your local digital twin partner. Please contact your Klinkman local sales and start your digital twin journey. Thank you to all from my side and enjoy. Please welcome first presenter Mr. Driton Salihu from Rockwell, Sweden.
Thank you, Pasi, for that introduction. So my name is Driton Salihu, and I'm a technology consultant from Rockwell Automation, and I'm here to talk about Emulate 3D and digital twin. So if we look at the agenda for this presentation, I'm going to cover the digital engineering, where I'm going to explain the term digital twin. After that, I'm going to cover the impact that digital twin and Emulate 3D could have on your business. After that, we are going to do a technology overview with all of the licenses that we have. And last but not least, I'm going to do a live demonstration of the software. So before we jump into the presentation, I want to show you a quick video. What we can see here is a virtual beverage plant created with Emulate 3D. Before building a plant, you will love to see how it will look like at the plant floor. And as we can see here, there is an issue with the operator will have difficulties to see one of the light towers at top end. So what's great about using virtual reality for automation application is that it will give us a very natural way to see what a piece of equipment will look like. This model is of course connected to a PLC controller, and as you can see, it is possible to interact with the model. We can from the HMI screen see the machine running live, and we can from the virtual environment push buttons for stopping the machine or running the machine, as we can see in the video. So that is how it can look like in a virtual world. Here we're using virtual reality glasses to interact with the machine. So if we start with the term digital twin, what is it and how can it help you? Probably a lot of you already heard this term before. If you haven't heard it before, then you will most likely hear it more and more in the future. And actually now, as it is very popular and industries are quite interested in it, and they see the benefit with it. So if I just shortly explain the term, it's a replica of a physical entity where the physical and the virtual world are bridged together, and where data is transmitted so that the virtual entity coexists simultaneously with the physical entity. So what can a digital twin help you with? It can improve the design, the commissioning, and the operation phases of your project. I will come to this later on in the presentation. Gartner, which is a well-known global research firm, estimated that half of the largest industry companies will use a digital twin by 2021, and that it will achieve a 10% improvement in effectiveness. I want you to imagine that you are building a new machinery or maybe just upgrading an existing one. There are some typical headaches and stress that will come with it. For example, operator will need training for new machine. Machines need to be redesigned for new demands. Drawings need to be updated. the window to actually bring the machine online and running it is quite small. You can only do that between production stops. Actually, this is where it takes more time than expected, and this is where it costs a lot. So there are many things that are dependent on each other. You can't test controls until the machine is built. You can't start production until it passes all of the FAT items. You can't start operator training until the machine is on site, of course. So what if you could run a lot of the development and testing in parallel rather than in a sequential order? Or what if you could test your exact routines of the code that you have on a fully functional model? Or what if you could train operators not on just ideal operations, but in various fault and troubleshooting scenarios? So all of those what-ifs on the previous slide achieves 4 outcomes that will have dramatic effect on our project. So the first one is throughput analysis. If a machine is upgraded, what impact will that have on your throughput? If you could analyze various configuration, could you make a more informed decision? What if there are changes in the demand, like for example changing a new package size? How will that affect the throughput? So these scenarios will be tested with Emulate3D, and you can be certain that the throughput will be improved. The next one is machine prototyping. You usually don't have the luxury of prototyping once a machine hits production. The only downtime you may have could be a scheduled shutdown, but every minute of that shutdown counts, of course. Why not experiment with machine design in the virtual environment? You can not only test new technologies, but improve it as well. Third one is virtual commissioning. Virtual commissioning is a source of unexpected cost and risk of any project. An OEM here anticipates not only how their new machine will operate, but also how it will be brought online and how the operators will be trained. While the end user has to anticipate how long it will take how long they will provide resources on site, and how long they will tolerate actually the production being shut down. So a lot of the risk lies in the team's abilities to conduct controls testing their code, which unfortunately happen that there are always some bugs on the code, and it takes time. So if we could continuously conduct controls testing during the design and confirmation, how will that affect the throughout? The fourth one is operating systems. Operating training. With a digital model of a machine, you're able to not only just train for ideal operations, you can imagine many scenarios that you want to be prepared for. You can simulate common faults, loss of communication, machinery malfunction, etc. Okay, so those digital engineering values that we went through last slide allow us to mitigate risks in a project. We know that each project has a plan, and rarely do things go accordingly to a plan. In reality, the design takes a little longer. For example, the requirement changes. Then manufacturing takes a little longer as well. Lead times are drawn out, for example. And finally, commissioning. It's here where there are always surprises when you find new faults and error codes. But if controls testing could be conducted through the project instead of the near end of the project, trouble areas could be spotted sooner, and if we start the operator training as soon as possible, then it would be much more time for the plan to be realized on time. So all of this means lower risk in projects, better trained operators at the end user site. It means less time taking a line down to install new equipment and more time in production. So Emulate 3D offers the link between PLC logic and 3D CAD models. Today, you have 3D CAD drawings representing the physical property of a machine and the PLC code that runs or will run the design once it is built. So with Emulate 3D, you can assign kinetic and physical attributes to the CAD model to make it so it's alive, so to say. And then you could like link the digital model to your PLC code, where you can run your PLC code alongside with your model to see exactly how your machine will operate. I'm going to show this later on the live demonstration and how it works. Now let's have a look at the 4 licenses level of Emulate 3D software package. First off, we have Layout 3D, which is the basic package for static models. Layout 3D creates accurate and realistic looking 3D layouts for catalog items and imported CAD. You can create fly-through videos to demonstrate, explain, and develop project ideas to all stakeholders. The next one is Demo 3D. Demo 3D contains the functionalities of what Layout 3D has, plus some dynamic models and physical features. Demo 3D allows a wide range of equipment to be prototyped and tested with different controls and operating logic. Demo 3D models reduce the physical prototyping necessary to develop new machines and are a powerful way to demonstrate operation to project stakeholders. The third one is Sim 3D. Sim 3D contains the functionality of what Demo 3D has, but with the addition of experimentation and analysis. Sim 3D allows modeling of your overall system, line process and flow. The overall flow through a system can be studied and developed, and the optimum dimensions of racks, conveyors, and storage areas can be determined. Equipment speeds like cycle times and maintenance schedules can be integrated as well. The fourth one is Emulate 3D, which has all of the Demo 3D characteristics, but it can additionally connect to an external controller. It has the highest end product that offers complete simulation precision and logical testing. This models the kinematics, the physics, and all of the constraints of your CAD model, while operating according to your PLC logic, of course, which means that you will save time and money doing controls testing. Emulate 3D, Sim 3D, and Demo 3D contains multiple powerful physical engines, as well as kinematic mechanism solver. These calculations are run dynamically, allowing us to manipulate the model as it runs. There are also a number of different collision geometry types, allowing complex shapes to be represented with configurable mass, center of gravity, and friction materials. These physics engines are designed for discrete, non-deformable objects. If you think of like plastic parts or like packages. So fluid or soft bodies are not supported at this time. So Emulate3D allows connection to external controllers through protocols such as Ethernet IP, TCP, UPC UA, TwinCAT, Profinet, and many more. It's also possible to connect to different PLCs, soft PLCs, warehouse management systems, robot controllers, and other systems as well. As you can see here, Emulate3D is an open ecosystem that allows the user to be flexible in selecting segments leader that all work together. For example, Emulate3D can interact with most of the major CAD drawings solutions, meaning that changes that you do on, let's say, SolidWorks will be fed into Emulate3D environment as well. So you don't have to do it twice. It's also a multi-vendor support for CAD system. You can have different, you can import different CAD files, but it's also important that you can use different control systems. So it's not only Rockwell PLCs, but you can connect to Schneider or Omron or even Siemens PLCs. So when it comes to building a fully functional model, the benefit is that you can create catalogs, objects, as you can see here. And what you can do is that you can develop it many times over and over and build a quite big system quite fast and easy. And I will show this on the live demonstration as well. So Emulate3D offers many logic operations for all level of experience and complexity, meaning that you can create more complex behavior of objects by writing your own code if you want to. So if you add like CAD drawings, you can do writing more code to that, so it's more complex. You can write it in either C#, JScript, or QuickLogics. And we have also something that we included, our ladder-style control logics in this software. As we saw in the video in the beginning of the presentation, with virtual reality we can view any model, manipulate load, press buttons, and HMI screens. And whenever it's unsafe or costly or disruptive to train operators on a real system, we can do it in Emulate3D's virtual reality environment. As we can see here in this video here, the operator is setting up a system and just training on how to build it. So there are many ways in which virtual reality can help, from demonstrating a model to virtual commissioning. So that's that with the presentation. I want to jump into the demonstration of the software. So I need to share my screen. And let's open the software here. So this is how Emulate3D environment looks like. Here we have the catalogs. These you can add own catalogs, like adding your 3D CAD drawings. But there are already some pre-installed catalogs like carton system, baggage system. We have vehicles like AGVs, trucks. We have a lot, and we have the robots as well. And in the store, we have more catalogs that you can download and operate with. At the top here, we have something that is called the CAD is the model, and this is how you need to use these to do the markup of the CAD drawings if you want to. You can add joints, motors, and different physics. Down here we have the prototypes, properties, I mean, and this is where you change the properties of the CAD drawing that you have. So let's add a basic conveyor belt here. What we see here is that what we can do here is that we can drag these points here and change the dimension of the CAD. It's pre-configured and parametric, meaning that when we change this attribute, we change the properties of the value as well. And you can see that to the left here. We can also, as the conveyor has a motor, we can change the properties of a motor as well, of the conveyor, or different materials of the motor, for example, or the conveyor belt. What we have here is something called the load creator. What it does, it creates some load. We can add our own loads as well, but here we have some predefined loads, like pallets and different boxes. So if we start this system, we will see that it will generate loads, and the loads are like you can change them and see how they will work, and if there's any obstacles on the load, and see how that affects. We also have attribute parameters as the speed and the acceleration of the conveyor belt, and the on and off state as well. What we can see here, if we can see the physics of the load and the belt created. For example, here we can see the friction that is created from the load and the conveyor belt. We change the material. So here, as we said, we have the motor characteristics, we have the forward, and we have the on and off state. So all of these properties we can change and interact with the PLC code if you want to. So let's do something else now. Let's add a cartoon belt, and as you can see, it's quite easy. Just drag and drop. So we can create many things here, and it's the same as copy pasting. You can create a new one, and what we see here is just by dragging it will snatch to each other. What this is a conveyor belt with a load creator and a sensor, and these triangles here are quite important, as they actually give us the communication network, meaning that the simulation engine and the objects can work together as a system automatically. So if we run this one now, the load creator will create the loads, and when this load hits the sensor here, it will send a signal to the load creator that it cannot take any more loads. So it can only create just one more load. If we build to this one even more, we add our robot. Let's add our cooker robot here. And to that robot, we need to add a vacuum tool. And as you can see, it snatches quite good. And we need to add our robot program as well. We need to assign this to the robot. And let's create 2 more loads on this side here, like this. So what we want to do now is that we want the robot to take the load that is created here and move it to one of these 2 conveyors. We need to do the connection path here as well. So we drag the end of this conveyor to the start of the robot controller, And we do the same with the end of this robot control to the start of these two conveyors. Then we have something here that is the homing. We need that so that when we start the system, the robot should know which position it is. So it goes to the homing position first. So let's see. First, the robot will go to the homing position. It will take the box here, and it will move to the other conveyor here. So what it does is like this conveyor will send a signal to the robot that there is a box, and you can grab it now and move it to the next conveyor. And it does the same here. So now this conveyor will send a signal to the robot that it already has a box and it cannot take any more boxes. And it's the same for this one. So now the robot should stop. This is just to show you how easy it is to build a fully working system. Let's go now to markup of a gantry here. So this is a CAD drawing that is just added. So what we need first to do is we need to mark it, meaning that we need to add some kinematic joints and motors and whatnot. So what we have here is the CAD drawing with the different parts. We have the carriage, which is this part here, and we have the beam, which is this part. So what we want to do is that this carriage should move in this direction, and the beam should move up and down. So by pressing this carriage here, we add a kinematic joint, kinematic prismatic joint to be more exact. And here in the aspect viewer, you see the joint added, and what it asks us for is in which direction this axis should be on. So we want it to move in the positive direction on that way. And then we have the mode. We choose inverse kinematics. And we need to put the up and lower limit. I know here that the upper limit is 59 inches. And if we run this now, we can drag it with the mouse. We can see that it moves in this direction. But as we can see, the Z-beam is not following with it. So we need to do the same for the Z-beam as well. So we press that one. We add a kinematic prismatic joint. We choose in which direction we want it to move. And then we add inverse kinematic. We put a lower and an upper limit. And here I know it's 35 inches. And now we need to create also the base, meaning that when this carriage moves, the beam should follow with. So we do it here. We select the carriage here, and let's try the system. So it moves up and down. These parts are following with. What we need to do more is that we need to add some motors to this one as well. So we add a linear motor. We need to assign this joint to the motor. The control mode is target, and here we change the speed and the acceleration. We change it to 1. And we do the same for the Z-beam. We add a motor. We choose the motor connection for the joint to the motor, and we choose the target, and we change the acceleration and deceleration. So if we run this now, we can change the let's see here. We can see that it's gonna move. So what we want to do next is we want to connect this to a PLC controller. And there we are. We take the next part here. Here we have a grip as well. I didn't want to do the markup of the gripper, but it's the same as the previous one. But what we added here is some load creator that will create the loads, and the gantry will take the load and move it to the box here. So we have something called here the tag browser. What we do is this is where we connect the Emulate3D to the PLC. When we do that, we get the tags of the PLC code, and what we do is that we load the tag, and then we bind these tags to the different properties of the model. So now we have connected to our PLC, and if we bring up the PLC code, we can run we can put the system on run, and if we run the system, you can see that the beam is going down, but it is not grabbing the box. So what we can do here is we can go to the code, and we can, for example, from the HMI screen, I'm doing it now in the PLC code, we can stop the beam, and we can jog it down. For example, we want to jog it so it can grab the box. When we are satisfied, we teach the gantry to pick it up, and if we run the system again, now the beam will take the box. So this is like controls testing, as I said. So this is quite important, because usually, like as I said, the plan of a project is the design. Then we have the development, and then we have the commissioning. And as I said, the commissioning is the most critical part, where for example, the automation engineer doesn't have a lot of time to do the controls testing. So what we can help is with this software to do the controls testing and prevent some different things like this one here. And it's quite a simple one, but it is quite instructive. Yeah. So if we go back to the presentation. So yeah, this is the first one that we did, and that is the conveyor, the gantry. So I will give it up to Kai, and I will answer any question if there's any during Kai's presentation.
Well, thank you, Dritten. I'll tell you about something about contracts in the use of digital software programs, and I will start my presentation with this kind of agenda. First, I will say a few words about myself, and I will introduce you with a case where there was a non-functional new factory which I was involved with. And then I will discuss about how to define the scope of a contract in a case where we design a customized manufacturing unit. I will review certain studies and review some certain grounds of claims that have been put up with it. And then I will go into what can we achieve by creating a digital twin, and how to implement a software program into contractual relationship, which will be interesting for a lawyer at least. And then I will make a short summary and answer to questions if you have any to ask. And first, a few words about myself. I'm an attorney at law. I'm a partner at a Finnish law office and specialized in business law. I have over 30 years experience of conducting both practical operative business and business law. So have been working as a sales director in an operative company also. I specialized, among others, ICT law as well as technology distribution agreements. So one of my main duties is to draft agreements and then handle all kinds of disputes in relation to agreements. So I see the agreements in the beginning, and also if they haven't succeeded, then also in the end of problems, when problems arise. I'm a standard group member also in the Finnish Standardization Association and work with these ISO standards, as you can see. Well, first I will introduce you with a case which I was engaged in a few years back. The case was that there was a new factory with a completely new setup and mindset. There were several suppliers of machinery and other production units, so there were conveyors, machineries in those lines, and many of those machines and production lines were designed for specific purposes, and those purposes were defined by customer. The contracts were fairly normal. They were standard delivery contracts, and they used standard contract terms such as Orgaline terms, which are, I assume many of those you are very familiar. But of course they had then on the top of these Orgaline terms and conducts, they have drafted different agreements. This factory, when it was commissioning, had pretty hard problems. There was a poor failing interoperability. There were production failures, high waste rates in production. There was a slow lead time, several unplanned interruptions of production, and they had to, in order to come over these problems, they had to redesign the already delivered production machineries, and that caused delays and additional costs. And there was a claim, and there was a big claim. In fact, it was a $1 million worth claim, and the problem was that from the purchaser's side, they had lost a lot of production materials, also lost of customers, and the damages to the factory side were extremely high. On the other side, those suppliers of machinery had thought that this factory would have been a window for the new machineries, so they had thought that they could make a reference of this new factory. So they had also a problem with this malfunctioning and disputes. But let's leave the case for a little bit aside and go into the what we think about in drafting a contract, namely scope of contracts. There is an international association of contracts and commercial management named IACCM, and they make a long-term study for international contract terms. Recent was made at 2018. And at this study, they ask more than 2,100 organizations globally what those negotiators who negotiate international contracts consider most important factor. And the number one has been, for several years now, scope and goals of specifications of the contracts. As you can see from the slide, there are also other very important terms and conditions which are to be negotiated, but still the scope and goals remain the most important, at least as these negotiators consider. So that means that these issues should have been then discussed and take the most of the time when you are negotiating the contract. So according to our experience, most problematic claims in relation to delivery machinery or assembly lines are based on failures which relate to specifications, which is product environmental capacity, or the scope of the delivery contracts in general. And the problems stand out especially in cases where we enter into a contract where the product doesn't exist in reality, or the existing product has to be modified or redesigned according to customers' needs. And what we have found out is that the problems are created in the beginning of where the machine is being purchased or designed, although they might be then discovered at a later stage. So if there is a dispute in a delivery contract, one of the main grounds for that dispute is that there is a breach of contract and that the supplier has made poor quality. And but we, as handling also disputes, have found out that most of the problems are results of poor or erroneous information, documentation, or both. And the problems are not resulting from poor quality, lack of professional skills or experience. They are not resulting from negligence or disregard, and they are not resulting from intentional misleading. So either the seller or buyer have done nothing wrong, intentionally or otherwise, and thus neither of them has breached any contractual obligation. So how would you solve a dispute of this kind where there is actually no one to blame? And to be more precise, the problems arise of lack of information or understanding of the conditions for the equipment, the use or production environment, the capacity or similar capabilities, the needs of interoperability with other products, assembly lines, etc. So if these matters are not communicated between the buyer and seller, they are not in the scope of the contract. They are not taken in consideration when designing and delivering the product. So that's why the scope of contract is so important, and many of us may also fail to see that point of view when we are negotiating a contract. Of course, you can update the contract scope at later stage, but in many cases this will cause unexpected delays, or it will be far expensive than if these matters would have been taken in the beginning. So now moving to digital twin and how to implement them on contracts. So as we have heard, we can create a lot of things with software which creates a virtual twin. We can model and visualize in the early stage the functions and functionalities of the product, the dimensions of the product, capacity of the product environment, and its restrictions or limitations. We can model the interoperability with other products and the feasibility of the intended use of the product. So this kind of modeling and visualization obviously may hinder many problems at later stage and save a lot of time and costs for both buyer and the seller. And as a lawyer drafting contracts, we see that the modeling and visualization may create better trust and accountability between the seller and the buyer, and that's, for lawyers' standard point of view, it's very important. So by creating a virtual model of the product to be delivered, we can, of course, as you could see, start programming the virtual product, inserting and feeding real-time values into the product, testing the virtual product in a virtual environment, and if they meet the specifications requirements of the reality. And if we go into contractual obligations and try to implement this virtual world into a contractual world, we could try creating a digital proof of concept, which prove the material capabilities of the product to be designed, manufactured, and delivered. We could also implement the proof of concept into the contract terms, a part of the scope of the contract. And by that, we can take the proof of concept as a starting point of a product design, and we can confirm the proof of contract in the contract, the trustworthiness of and validity of the digital proof of contract, and all related parameters and other specifications. So, in addition, we could agree on a digitized change of product management, which would be a process accepting and executing changes in the digital twin and later to the real product. The digitization of contract could save time and costs considerably when accepting the changes in the design and operation functions of the product. And the final product to be delivered and updated virtual twin can both be tested in a virtual world and in a real operational environment, as you could see from the previous presentation. We can also feed sensor and other data from the operational environment into the virtual twin and thus test the product in reality and in the virtual world and vice versa. And the possibility to check the product's capacity, connectivity with other machinery production line and test, monitor and assess the products and production line functions, capacities, etc. will again create, as a lawyer's point of view, better trust and loyalty between the buyer and the seller. It can strengthen the contractual relationship, finely said, but actually it's what the contracts are all about. It's about strengthening the relationship between the buyer and the seller, and most important, secure success of their joint efforts. Well, after the delivery, we can continue developing the product in virtual world by using the real-world data created and or collected during product's operational use in the real-world operational environment. And by that, we can confirm the contractual targets if such measurement and conformity is agreed. The operational data can be collected and fed continuously into the digital twin, test it in digital format, and receive new data and information concerning products, lifetime, wear, service, and maintenance needs. And that creates quite a new world to the machine producent and also for the purchaser of the machinery, because this new data is valuable and it can be used to create a new business and pricing models, and of course developing related contracts. Well, go back to the case which I was in the beginning explaining. The contracting parties had made several specifications and drawings and similar documents. So as I said in the beginning, the contracts were very carefully drafted. There were standard terms and conditions. The documents were attached and referred to the delivery contracts. And all suppliers had made several visits and inspections at the site, but the factory was still under construction. Since the factory was not ready, the parties had been reviewing the product drawings and specifications and compared them with drawings of the factory. And if they would have had these emulated 3D or similar digital 3D programs with virtual twin, they would have found significant problems already in the beginning in testing them, and this would have had significant impact on this case. and most likely there would have not have been any case, which would have been, of course, for the parties involved, the best case. So during the purchase and redesign process, parties would have noticed these issues, which had considerable influence on the products, their functions, operability, and capabilities. Both parties would have had far better understanding of each other's expectation and needs. The seller and buyer would have been able to test the digital twins of products before the actual products were delivered and assembled in the factory. Probably not all, but at least most of the critical problems would have been avoided. The seller and the buyer would have saved considerable time and money when using these kind of products or other tools. So, few summary and final words and questions. I'm on the opinion that we should use all possible means to help contracting parties to define the scope of the contract. As you could see from the study and my previous information, the scope of the contract is very, very important, actually one of the most important things in the negotiations. A vague scope of contract is a considerable risk. Using a software program to demonstrate the scope of the contract saves both time and money for all parties involved. So from the supplier, also from the purchaser side of view. A contract needs not only be formally correct, it needs to be fit for its purpose and understood properly. And this is actually the main thing what we are talking now. In the light of above, software demonstrating the scope of a contract is a useful tool, and it's worthwhile at least to be considered. So if you have any questions about this contracting and improving it with digital products or digital software, I'm pleased to answer any questions in this during this webinar or later on. Thank you.
Thank you.
Thank you, Kai, and your valuable presentation. And all the attendees, I hope you will getting the ideas how to use Emulate 3D software to increase your productivity. Yes, but before we close the webinar, now it's time to questions. Okay, thank you.